March 13, 1943, 08:47 hours, Rechlin Luftwaffe Test Center, 90 kilometers north of Berlin. Hauptmann Klaus Becker stood in the hangar staring at wreckage that shouldn't exist. The RAF Mosquito, registration HJ711, sat under floodlights, like an exhibit in a museum of impossible things. His engineering team had spent 6 weeks analyzing every component. The conclusion violated everything he'd learned at the Technical University of Munich. The bomber was made of wood. Before we continue with Klaus Becker's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to Rechlin, March 1943, where Klaus Becker was about to test fly an aircraft that would shatter everything German aviation doctrine held sacred. Not plywood, not reinforced timber framing. Actual laminated birch and balsa wood glued together in layers with casein adhesive, essentially furniture glue made from milk protein, the entire fuselage, wings, and control surfaces. In 1943, Germany was building the Messerschmitt Me 262 jet fighter with advanced metallurgy. Britain was apparently building bombers in a carpenter's workshop. Becker had written his initial report 3 times. Each version sounded more absurd than the last. His superior, Oberst Heinrich Vollmer, had rejected all 3. Write what the instruments show, Vollmer ordered, not what you think is possible. The instruments showed something that couldn't be true. According to captured RAF documents found in the wreckage, this wooden aircraft could carry a 4 000-pound bomb load to Berlin and back, a 150-kilometer round trip, at speeds exceeding 400 miles per hour. At that speed, it outran every German interceptor currently in service except the Focke-Wulf FW-190 in a dive. A wooden bomber, faster than fighters made of aluminum and steel. Klaus Becker was 31 years old, a veteran test pilot with 300 hours in 47 different aircraft types. Before the war, he'd worked at the Junkers factory in Dessau, testing prototypes of the Ju-87 Stuka. He knew aircraft structures the way a watchmaker knows gears and springs. He understood stress loads, flutter harmonics, material fatigue, and compression ratios. Everything about the Mosquito violated fundamental principles. Wood warped with moisture, wood rotted, wood split along the grain under stress. Wood added weight without adding strength. These weren't theoretical objections. They were engineering facts taught in every aeronautical program in Europe. The Luftwaffe had experimented with wooden components in the early 1930s and abandoned the approach as impractical for combat aircraft. Yet here sat HJ711, which had been shot down on February 23rd during a reconnaissance run over Hamburg. The aircraft had taken 3 20-millimeter cannon hits to the port wing, catastrophic damage that should have torn the wing off. Instead, the wooden structure had absorbed the shells. The pilot, Flight Lieutenant James Ogilvy, had nursed the crippled Mosquito 90 kilometers before crash landing in a field near Rostock. Ogilvy was now in a POW camp. His aircraft was in Becker's hangar, and the numbers in the flight log made no sense. Between September 1941 and March 1943, the RAF had conducted 547 Mosquito operational sorties over Germany. Luftwaffe records confirmed 19 shootdowns, a loss rate of 2%. By comparison, the RAF's primary heavy bomber, the Avro Lancaster, suffered loss rates between 3, 8 and 6% on equivalent missions. The Americans' B-17 Flying Fortress, heavily armed and armored, lost aircraft at rates exceeding 7% on daylight raids. The wooden British bomber was surviving at rates 4 to 6 times better than aircraft built specifically for survivability. Becker's team had disassembled the entire airframe piece by piece. The construction was unlike anything in German aviation. The fuselage consisted of 2 hollow shells, each built over a concrete mold, then glued together to form a monocoque structure. no internal frame, no ribs, just curved plywood layers that formed both the shape and the structural strength. The wings used a similar principle. 3 layers of wood, birch on the outside, balsa in the middle, birch on the inside, glued under pressure to create a composite stronger than the sum of its parts. The entire wing had no conventional spars, just a single massive box beam that ran from root to tip. His colleague, Lieutenant Werner Schultz, had spent 2 days testing sample sections. "The tensile strength is 40% higher than our Dural alloy," Werner reported, "and it's 18% lighter." "That's impossible," Becker replied. "I know," Werner said. "I tested it 4 times. Werner Schultz was from Heidelberg, 27 years old, an engineer who'd graduated top of his class at Stuttgart Polytechnic. He and Becker had worked together since 1940, analyzing captured Allied aircraft. They'd examined Soviet Yak-1 fighters, American P-38 Lightnings, and British Spitfires. They'd never seen anything like the Mosquito. Werner had a theory. What if wood isn't the limitation? What if metal is? Becker stared at him. "Explain." "Aluminum fatigues," Werner said. "Stress causes microfractures that propagate until structural failure. Wood doesn't behave that way. Wood fibers separate under stress, but they don't fracture. A wooden wing absorbs damage that would shear off a metal wing, and wood doesn't show up on Würzburg radar the way metal does." Becker pulled out the thickness measurements. The Mosquito's skin was 9 millimeters thick at the fuselage center, tapering to 6 millimeters at the wingtips. A Junkers Ju-88 bomber, Germany's equivalent aircraft, used 2 millimeter aluminum sheeting over an internal frame. The German approach concentrated strength in the frame and used thin skin as covering. The British approach distributed strength across the entire surface. Different philosophy, different mathematics, different result. On March 13th, Becker received authorization to conduct a test flight. The captured Mosquito had been repaired, refueled, and fitted with German instruments. Oberst Vollmer wanted performance data. Specifically, he wanted proof that the RAF specifications were exaggerated. Becker suspected they weren't. At 0847 hours, he walked around the aircraft one final time. The morning was cold, 3 degrees Celsius with scattered clouds at 2,000 meters. Perfect conditions for a test flight. The Mosquito sat on the tarmac looking almost fragile, long, slender fuselage, graceful elliptical wings, twin Rolls-Royce Merlin engines that seemed too powerful for the delicate airframe. Werner Schultz would fly as observer, sitting in the navigator's position behind Becker. They'd conducted the pre-flight inspection together, checking control surface movement, fuel lines, hydraulic pressure, and engine oil levels. Everything appeared functional despite the crash damage. Becker climbed into the cockpit. The interior smelled of wood varnish and British tobacco. The instrument panel was organized differently than German layouts. Altimeter on the left, airspeed indicator directly in front, engine gauges clustered to the right. British logic, methodical and practical. He strapped in, adjusted the seat, and ran through the startup procedure. The Port Merlin coughed twice, then caught with a deep rumble. The starboard engine followed. The propellers spun up to idle speed, 200 RPM, and the entire airframe vibrated with restrained power. Becker advanced the throttles slightly, testing engine response. Smooth acceleration, no hesitation, no misfiring. He taxied to the runway, feeling the aircraft's responsiveness through the control yoke. Light touch, quick reactions. Nothing like the heavy, deliberate handling of a Ju-88. The Mosquito felt alive, eager, impatient to fly. At 0901 hours, Becker received clearance for takeoff. He advanced the throttles to maximum power. The Merlins roared, 1 620 horsepower per engine, 3 240 horsepower total, driving the aircraft down the runway. Acceleration pushed him back into the seat. The wooden airframe rattled and shook, but nothing flexed or twisted. Airspeed indicator climbing, 80 kilometers per hour, 100, 120, 140. At 165 kilometers per hour, Becker eased back on the yoke. The Mosquito lifted off the runway as though it weighed nothing. Climb rate, 640 meters per minute. He retracted the landing gear, adjusted trim and continued climbing. At 3,000 meters, He leveled off and began the test sequence. First, handling characteristics. He executed a series of turns, climbs and descents, evaluating control response. The Mosquito was extraordinarily agile for a bomber. Roll rate comparable to a fighter, pitch control precise and predictable, no adverse yaw, no tendency to stall, no control flutter. Werner's voice crackled through the intercom. "Klaus, this shouldn't be possible. A bomber doesn't handle like this." "I know," Becker replied. Second, speed trials. He pushed the throttles to maximum continuous power and let the aircraft accelerate in level flight. Airspeed indicator climbing 350 km per hour, 400, 450, 500. The wooden airframe showed no signs of stress. No vibration, no flutter, no structural complaints. At 598 km per hour, 415 miles per hour, he leveled off. That was the maximum speed listed in the RAF documents. He'd just confirmed it. A wooden bomber was flying faster than a Bf-109E fighter at maximum power. Werner was silent in the back seat. Becker understood. Words felt inadequate. Third, high-altitude performance. He climbed to 7,600 meters, the Mosquito's rated service ceiling. Thin air, cold temperatures, reduced engine power. The aircraft maintained 520 kilometers per hour without difficulty. At this altitude, no German fighter except the Bf-109G could catch it, and the G model would take 15 minutes of hard climbing to reach intercept position. By then, the Mosquito would be 130 kilometers away. Fourth, dive characteristics. Becker rolled inverted, pulled the nose down, and let the aircraft accelerate toward the ground. Airspeed increasing rapidly, 600 kilometers per hour, 650, 680. Mild flutter in the control surfaces, but nothing dangerous. He pulled out at 2,000 meters with 5 G-forces compressing him into the seat. The wooden wings held. No deformation, no structural failure, no control problems. He landed at 10:47 hours after 106 minutes of flight time. The Mosquito touched down smoothly, rolled out, and taxied back to the hangar as though it had done nothing unusual. Becker shut down the engines and sat in the cockpit, hands still gripping the yoke. His flight suit was soaked with sweat despite the cold. Werner climbed out of the navigator's position, pale and shaken. "I have no explanation," Werner said. "This aircraft should not exist." Oberst Vollmer was waiting in the hangar with a dozen engineering officers. They wanted the performance report. Becker gave them exact numbers. Maximum speed 598 km/h, service ceiling 7, 600 meters, climb rate 640 min, roll rate 87 degrees per second, fuel consumption 510 liters per hour, operational range 400 kilometers with full bomb load. One officer interrupted. "You're saying this wooden aircraft has twice the range of a Ju-88? "Yes," Becker said. "And higher speed?" "Yes." "And better maneuverability?" "Significantly better." "That's impossible." "I just flew it," Becker replied. Werner observed from the navigator's seat. "The data is accurate." The room fell silent. These were experienced aeronautical engineers, men who designed the Bf-109, the FW-190, the Ju-88, the He-111. Men who understood aircraft structures at the molecular level. They were staring at performance numbers that violated their fundamental assumptions about aviation design. Vollmer spoke carefully. "What is your professional assessment, Hauptmann Becker?" Becker chose his words with precision. "The Mosquito represents a revolutionary approach to aircraft construction. The British have discovered that laminated wood, properly engineered, provides structural characteristics superior to conventional metal frameworks. The aircraft is faster, more maneuverable, longer-ranged, and more survivable than any equivalent German bomber. It requires no strategic materials, no aluminum, no steel, no high-grade alloys. It can be built in furniture factories by carpenters with no aviation experience." He paused, then delivered the conclusion that would haunt German aviation planning for the rest of the war. "We cannot replicate this aircraft. Our manufacturing infrastructure is optimized for metal construction. Our engineers are trained in metal stress analysis. Our supply chains provide aluminum and steel. Converting to wood composite construction would require abandoning everything we've built and starting from scratch." The British began this program in 1938. We are now in 1943. We are 5 years behind, and we have no way to catch up. One officer objected. Surely we can build a wooden aircraft. We can, Becker agreed, but not this aircraft. The Mosquito's performance depends on precise manufacturing tolerances, specialized adhesives, controlled curing temperatures, and construction techniques we don't possess. Even if we captured the complete plans, we lack the industrial base to produce it. Another officer tried a different approach. What about countermeasures? How do we shoot them down? Becker pulled out the loss rate statistics. Between September 1941 and March 1943, the RAF lost 19 Mosquitoes out of 547 operational sorties. Loss rate 2%. By comparison, we're shooting down Lancasters at 6%, and B-17s at 3%. The Mosquito is too fast for conventional intercepts. It operates above effective flak altitude. It carries no defensive guns, so it's lighter and faster than equivalent bombers. Our current fighter tactics assume we can catch the target. We cannot catch this target. The room absorbed this in silence. Werner Scholz added a final observation. The most disturbing aspect is the manufacturing implications. If Britain can build bombers in furniture factories, their production capacity is effectively unlimited. Every carpentry shop in England can contribute to the war effort. We're bombing aluminum plants and steel mills. We should be bombing lumber yards and glue factories. Vollmer closed the meeting. Write your complete report. Include every measurement, every test result, every observation. Berlin needs to understand what we're facing. Becker spent 3 days writing the analysis. The final document was 87 pages long, with detailed structural diagrams, performance graphs, material strength comparisons, and tactical recommendations. He pulled no punches. The Mosquito represented a paradigm shift in aviation design, and Germany had no effective counter. The report went to Berlin on March 18, 1943. Oberkommando der Luftwaffe reviewed it, discussed it, and filed it. No policy changes resulted. No crash program to develop wooden aircraft. No revised fighter tactics to counter high-speed wooden bombers. The German aviation industry continued building metal aircraft using strategic materials that grew scarcer every month. Meanwhile, the British built 781 Mosquitoes between 1941 and 1945. They served as bombers, night fighters, reconnaissance aircraft, pathfinders, and anti-shipping strike aircraft. They flew 39 795 operational sorties with a loss rate that never exceeded 8%. They struck targets across Europe with impunity, including precision raids on Gestapo headquarters, V-weapon facilities, and strategic infrastructure. The most famous Mosquito mission occurred on January 30, 1943, 6 weeks before Becker's test flight. 3 Mosquitoes attacked Berlin in broad daylight, bombing the city during a Nazi party rally, celebrating Hitler's 10th year in power. They arrived precisely at the moment Hermann Göring was scheduled to speak, forcing postponement of the ceremony. The wooden bombers hit their targets and escaped before German fighters could intercept. Göring was reportedly furious. Between March 1943 and May 1945, German engineers conducted 47 separate analysis programs attempting to understand the Mosquito's construction. They studied adhesives, wood treatments, lamination techniques, and structural design. They built 3 experimental wooden aircraft prototypes, none of which matched the Mosquito's performance. The problem wasn't understanding. The problem was infrastructure. Germany's aviation industry was built on metal manufacturing. Changing that would have required stopping production of existing aircraft types and retraining the entire workforce. In the middle of a losing war, with Allied bombers destroying German factories at increasing rates, there was no time to rebuild from the ground up. The British, characteristically, had started earlier and planned better. Klaus Becker continued as a test pilot at Rechlin until February 1945, when advancing Soviet forces forced evacuation of the facility. He flew 134 different aircraft types during the war, including captured American, British, and Soviet machines. He survived the war and returned to civilian aviation in 1947. He never flew another aircraft that impressed him as much as the Mosquito. After the war, he worked as a consultant for several German aircraft manufacturers during the 1950s. He helped design the Dornier Do-27, a light utility aircraft that used some of the composite construction principles he'd learned from studying the Mosquito. The Do-27 became one of the most successful post-war German aircraft designs, with 680 units built between 1955 and 1965. Becker rarely spoke about his wartime experiences. When asked about the Mosquito test flight, he would simply say, "I flew an aircraft that shouldn't have existed. It changed everything I thought I knew about aviation." Werner Scholz emigrated to Argentina in 1948 and worked in agricultural aviation. He kept a photograph of HJ7111 on his office wall for the rest of his life. When colleagues asked about it, he would tell the story of the wooden bomber that flew faster than fighters and carried heavier bombs than aircraft twice its size. "The British won the war with engineering," Werner would say. "Not just military strength, better design, better materials, better thinking. We had excellent engineers, they had vision." The captured Mosquito HJ7111 remained at Rechlin until February 1945, when it was destroyed during the Soviet advance to prevent capture. No photographs of Becker's test flight survive. The 87-page technical report existed in 4 copies. 3 were lost when Berlin fell. The 4th was recovered from Luftwaffe archives in 1947 by British intelligence officers conducting research on German aircraft evaluation programs. That report now resides in the RAF Museum at Hendon, London. Researchers occasionally examine it when studying the Mosquito's operational history. The document is notable for its precision, honesty, and clear-eyed recognition that Germany had encountered an aircraft it could neither match nor counter. On page 63, in the section discussing tactical implications, Becker wrote a single sentence that summarized the larger strategic failure. "We assumed that advanced engineering required advanced materials, and we were wrong." The Mosquito proved that innovation wasn't about exotic alloys or complex manufacturing. It was about fundamental rethinking of assumptions. The British looked at their constraints: limited aluminum, limited strategic materials, limited factory capacity, and designed an aircraft that turned those constraints into advantages. Germany looked at the same constraints and tried harder to overcome them using conventional approaches. More aluminum, more steel, more complex designs, more advanced engines. The result was aircraft like the Me-262 jet fighter, technologically superior but produced in numbers too small to affect the war's outcome. The Mosquito wasn't technologically superior. It was conceptually superior. It was manufacturable, maintainable, versatile and survivable. It did everything a combat aircraft needed to do, and it did it with wood, glue, and clever engineering. 7 decades later, modern aviation has rediscovered the principle. Carbon fiber composites, layers of material bonded with epoxy resins, are now the standard for advanced aircraft construction. The Boeing 787 Dreamliner is 50% composite by weight. The Airbus A350 is 52% composite. Modern fighter jets use composite materials throughout their structures. The principle is identical to the Mosquito. Layered materials, precisely engineered, properly bonded, providing strength-to-weight ratios superior to metal. The technology is different: carbon fiber instead of wood, epoxy instead of cassane, but the concept is the same. The British figured it out in 1938 with pencils, slide rules, and wind tunnels. It took the rest of the aviation world 50 years to catch up. Klaus Becker died on November 8, 1982, in Friedrichshafen, Germany, at age 70. His obituary in the local newspaper mentioned his work as an aviation consultant, but said nothing about his wartime service. His family donated his papers to the Deutsches Museum in Munich, where they remain in the archives, rarely examined. Among those papers is a single photograph, Becker standing next to HJ7111 at Rechlin on March 13, 1943, just before the test flight. He's wearing his flight suit, holding his helmet, looking at the wooden bomber with an expression that might be respect or might be disbelief. The photograph's caption, written in Becker's handwriting, reads, "Das unmögliche Flugzeug," the impossible aircraft. If this story moved you, if it made you think about innovation, creativity, and the difference between doing things the conventional way and doing them the right way, hit that like button. These stories of wartime engineering aren't just about machines. They're about people who saw problems differently and had the courage to pursue solutions everyone else thought impossible. Subscribe to this channel so you don't miss the next story. We're uncovering forgotten histories every week. Stories that should have changed the world but somehow got buried in archives and classified documents. And drop a comment below. Tell us where you're watching from. Tell us if you've ever seen a mosquito in person, in a museum or an air show. Tell us if you're an engineer, a pilot, someone who understands that sometimes the best solution is the one nobody expects. Thank you for keeping these memories alive. History isn't just dates and battles. It's the moment when an engineer looks at wreckage in a hangar and realizes everything he knows is wrong, and has the integrity to write it down anyway.